All right, we're going to have a look at yet another example of drawing direction fields. This time we're going to look at the direction field of the following equation. And then we're going to sketch in a few different solution curves. I'm just going to make some up and have a look and see where they go. All right, so you've got the idea about how to do these things. You essentially just take a number of test points, you plug them in, and you have a look at where they're going to go. This curve, this direction field, though, it's a bit more complicated because it requires a bit of care to draw this out. You'll notice that I've been quite sloppy in the last couple of examples where I've been drawing a few lines that are kind of close enough is good enough. I mean, that's about what we can achieve if we're doing this by hand. If we do this on a computer, obviously it's far more accurate. I'm just going to go through a table of points before I start to do my drawing now, though. So you can see the sort of thing that I'd end up with here. Right. You can imagine me keeping going, writing this table out. Okay, so dy dx is 4 plus 0 minus 1. 1 plus 0 minus 1. 0 plus 0 minus 1. 1 plus 0 minus 1. 4 plus 0 minus 1. 4 plus 1 minus 1. 1 plus 1 minus 1. 0 plus 1 minus 1. 1 plus 1 minus 1. 4 plus 1 minus 1. And so on, right? So we've filled in the first few lines of this. Now I'm going to draw out my axes. So minus 2, 0, 1, 2, and then I just did this line as well. All right, so now I'm going to try my very best to sketch in a slope of 3. Obviously doing that on a slope of 0 is very nice, that's easy. Slope of 0 occurs here as well. Let's get that one in. Slope of 1 occurs at minus 1, 1. So again, that's drawing like a little 45-degree angle. And it also occurs at 1, 1. So again, we try and draw a line with a 45-degree angle. 4 will have quite a steep angle. Right, 3 will be steep, but not as. That's 4. 3 will be steep, but not as steep. So we'll try and draw it like that. Okay. I'm not satisfied with that. That's too shallow. That's kind of the best I can manage. All right, so at 0, 0, we've got a slope of -1. So that's a 45 degrees, but pointing the other way. And now we probably want to fill in these values here to try and get an idea of what this field looks like. Now I'm just going to go ahead and pretend that I've worked out all these values because I've done that in the past, and I'm going to sketch them in as best I can manage. Oops. All right, so obviously there's something a bit funky going on in around here. There's obviously some very rapid changes in the derivative, so it's worth actually going ahead and doing a few extra points in and around that region to try and work out what's going on. So I just stick in the values as before. And it kind of starts looking a bit like this. And if we move a bit further out here, we'll see stuff kind of like this going on. And we start to see that there's going to be a bit of curvature in our solution. So this is going to be pointing up as well. That one's flat. This is kind of flat but tending up, and so on. This one will be sort of flattish but tending like that, and so on. Right, so hopefully you can start to see that that's what this solution curve looks like. Now, how I've done this is I've worked out all the derivatives well ahead of time. If you were doing this in a test, you would probably have to like keep going with this table. Now, let's sketch in some possible solution trajectories. Let's do one that sort of starts here. Remember, our solution trajectory and the direction field or slope field are locally tangent. So my solution is going to start looking like this. It's going to look like this. It's going to come down here. Now it's got to sort of turn around. It's got to somehow move to be tangent to this one. So it's going to go through a turning point. There's going to be a 0. This flat 0 is going to occur there somewhere as well. All right, so that's one of our solution curves. If we go back this way, we start to see that that's what our solution looks like there. But we also note that there's some different solutions that we can get. If we start down here, what's color I haven't really used? This one. If we start down here, we start locally tangent. We've sort of got to look like this. We're going to look like that. We're going to go up like that. So that's another solution. It starts somewhere down here. Could look like. Use the yellow color. If we start out here on this side of the green line, you can see that we can get a solution that looks like that. Somewhere in here, there's this magic solution that crosses that one there at 0 and then starts going up like that. But again, I really know this only because I've got access to a much finer resolved version of this picture that's been done on a computer. So in the sort of test, if you were sketching things that looked roughly like my blue line and my green line and my yellow line, I'd be pretty happy. I mean, I don't expect these hand-drawn pictures to be of great quality.